Assalamualaikum and a very good day to everyone. We are Chistab from CDCS1434C and today we will be presenting a video assignment for MAT263 linear algebra 1. We will be talking about magnitude of a vector and its application in daily life.
Let me introduce our team members. First, we have Kasrina Nadira binti Muhammad Nufadili 2022624162, Syazatul Husna binti Abdul Hamid 2022878894, and Nur Syahira binti Roslan 2022600246.
So this is the purpose of study. First is to understand the concept of a magnitude of a vector. Next is to understand how the calculation of magnitude of a vector is done. And third is to understand more about magnitude of a vector and relate it as application in daily life.
Okay, moving on to the introduction of a magnitude of a vector. The magnitude, or we call length, of a vector u is represented by the symbol u, as you can see in the video. It can be calculated by using this formula. Okay, we got three formula. Okay, for the first one, into space, the magnitude of a vector u, which is equal to u1 and u2, because it is into space, is a square root of u1 square plus u2 square. And for three space, of course we got u1, u2 and u3, and so the formula is u1 square plus u2 square plus u3 square, and then the sum of it, we need to square root of it. And for n space, or r power of n, the formula is square root of u1 square plus u2 square and so on until un square. Okay, let me give you an example. If we have the r power of 4, and then we need to square root them, u1 square plus u2 square plus u3 square and then plus u4 square, because we need to follow the power of r.
Now let's move on to example question for magnitude vector. So for the first example, we have magnitude into space. A vector b in a two-dimensional space is given by its component b vector equal to 5i plus 12j. Calculate the magnitude of b vector. So what we need to find? We need to find magnitude of the vector b, which is 5i plus 12j. So we insert into formula magnitude u1 square plus u2 square, and we get square root 5 square plus 12 square, and we get square root 169, and we get 13. Next, magnitude in three space. Given the vector v equal to negative c, 8, 10, find the magnitude of vector. So what we need to find? We need to find magnitude of vector v, negative c, 8, 10. So we insert into formula square root u square plus u2 square plus u3 square, and we just insert negative 6 square plus 8 square plus 10 square, and we just press our calculator and we get 10 square root 2 or 14.40. Last, magnitude in n space. It just use the same formula as before, u1 square plus u2 square plus un square square root. So let's see the question. Calculate the magnitude of p in that is in n space. So vector p, we have 3, negative 2, 5, 7, negative 1. So what we need to find? We need to find the magnitude of vector p, 3, negative 2, 5, 7, negative 1. We insert into formula. We get 3 square plus negative 2 square plus 5 square plus 7 square plus negative 1 square, square root. And we get square root 88. We just insert into calculator and we get 2 square root 22 or 9.38. So this is all the example question for magnitude space.
So this is the case study that we have came out with. So there's two cyclists, Sam and Chris. They are travelling along different paths. So Sam starts at the coordinates of 1, 2, 3 and Chris starts at the coordinates of 4, 6, negative 1. After some time, Sam arrives at the coordinate of 7, 5, negative 2 and Chris at the coordinate of 2, 3, 4. So we need to calculate the displacement vectors for both cyclists and determine the magnitude of each displacement vector. So finally, we need to find the distance between Sam's and Chris' final position.
Now, let's move on to methodology. To solve this question, we need 3 steps. First, calculate the displacement vector for Sam and Chris. Second, calculate the magnitude of displacement vector for Sam and Chris. Third, find the distance between Sam and Chris' final position. Now, let me show you the solution of those questions. For the first step, displacement vector for Sam. Sam start at coordinate 1, 2, 3 and move to coordinate 7, 5, -2. To find the distance, we just need to minus final coordinate with first coordinate. So we get 7 minus 1, 5 minus 2, -2 minus 3. And we get 6, 3, -5. To find displacement vector for Chris start at coordinate 5, 6, -1 and move to coordinate 2, 3, 4. So to find the distance, 2 minus 4, 3 minus 6, 4 minus -1. We get -2, -3, 5. Next, for the second step, we need to find magnitude of Sam displacement vector. To find the magnitude, we just need to insert Sam displacement vector into distance formula. A square plus B square plus C square square root. So, magnitude of Sam displacement vector 6, 3, -5. We insert into formula, we get 6 square plus 3 square plus -5 square square root, and we get square root 70 unit. To find the magnitude of Chris displacement vector, we get -2, -3 and 5. So we insert into formula, we get -2 square plus -3 square plus 5 square, and we get square root 38 unit. Last, find the distance between Sam and Chris' final position. Sam final position 7, 5, -2 and Chris final position 2, 3, 4. To find the distance between Sam and Chris, we just need to minus Sam minus Chris. So we got square root 7 minus 2 square plus 5 minus 3 square plus -2 minus 4 square, and we get square root 65.
Okay, moving on to the results and discussion. Okay, for the first step, we got the displacement vector of Sam is 6, 3 and -5, and displacement vector for Chris is -2, -3 and 5. Okay, how we attain this displacement vector is by subtracting the final positions of Sam and Chris from their previous positions, and then that is how we attain the displacement vector for them both. Okay, for the second step, we got the magnitude of Sam's displacement vector is 70 units and Chris 38 units. This is achieved by using the magnitude formula, which is x squared plus y squared and square root the sum of it. This formula is derived from the Pythagoras theorem. And the last step is the distance between Sam's and Chris' final position is square root 65 units, and this is achieved by using the distance formula, which is square root of x2 minus x1 square plus y2 minus y1 square, and this is the formula of the distance.
So in conclusion, the magnitude of a vector is very crucial in many academic fields. So understanding it helps us to grasp physical phenomena better and perform accurate maths. So whether we're studying forces, signals or shapes, knowing vector magnitude is vital. So appreciating this importance improves our ability to handle complex problems effectively.
So this is our references.
I would like to express my gratitude to everyone who contributed to the making of this video. Special thanks to our lecturer, Madam Samsia, for her guidance, our peers for their support, and our family for their encouragement. This project wouldn't have been possible without your help and inspiration. Thank you.